crosses the x-axis in two places. You could have a parabola where it just kisses the x-axis in one spot, which means we're going to get like a duplicate answer, like the answer is like x equals 5 and x equals 5. Or we could have a parabola that's kind of hovering above or below the x-axis. All right? So this has two x-intercepts, this has one x-intercept, and this has no x-intercept. So what we're going to do is try to predict which type it's going to be using some examples off your chart here with our calculator. I'm going to do the first one with you. So in your calculator, we're going to type in the very first equation. And we're just going to make an observation about how many times it hits the x-axis. Okay? So you're going to go to the y equals screen. Clear this out. So we're going to type in x squared plus x minus 6. If your graph doesn't come up, hit zoom 6. The first one. So how many times does this one hit the x-axis? 2 times. So I'm going to write a little 2 there. It has 2 x-intercepts. This little green paper that you have in front of you, most of them are green. Okay.
Number of x-intercepts.
Mm-hmm.
And that's what I wrote.
So this has 2 x-intercepts. Oh, okay, we're going to use this. There's a little formula on the right-hand side, b squared minus 4ac. If I look at this equation, what is a? 1. What's b? What's c? And I'm just going to plug it into this formula. So I have 1 squared minus 4 times 1 times negative 6. It would be really great if you'd stop some of this extra conversation. And then we're just going to compute that. So 1 squared, you can type it in your calculator. What do we get? No, just in the home screen. Just hit second quit. So this is 1 squared, that's positive 24, so that's 25. Okay. Now we don't know what this number here represents yet. That's what you're going to try to figure out. All right? You're going to make some observations about how this number here relates to the number of x-intercepts. Okay? And there's some questions on the next little part there that's going to ask you those questions. So take a few minutes with your group. If you want to divide this up, that would be fine. Okay, decide which one each of you are going to do. Then you can share results and then see what patterns emerge. Okay? The answer that you got when you did this formula? 44? All right, the third row. 1, it just kisses the x-axis, right? And what did this little formula equal? Should be 0. You need to put, if you have negatives and you're squaring a negative, okay, it's a positive. So negative 12 squared is a positive 144. In parentheses for your calculator. The fourth one, how many x-intercepts?
1.
What does the formula equal?
0.
Okay, the next one. How many x-intercepts?
0.
I'll go back. What did this one equal? Negative 8. Okay? It didn't cross the x-axis anywhere. Okay? So, if we look at our chart, if this last column was 0, how many x-intercepts did we have? 1. So if we use this little formula and we get 0, we know that the parabola is only going to kiss the x-axis. Okay? If the number of x-intercepts in the last column was negative, so if you get a negative, what do you notice about x-intercepts? 0. So it's kind of like hovering over the x-axis. It doesn't touch it anywhere. And if we get a positive answer, we know we're going to get 2 x-intercepts. Okay? This little formula that we're talking about that you used is what we call the discriminant. So, if b squared minus 4ac is positive, let me just write it in words, because otherwise you're going to get mixed up. Let me just write is positive. If b squared minus 4ac is negative, how many x-intercepts? 0. If b squared minus 4ac is 0, how many x-intercepts? 1. So we can predict how many x-intercepts or real zeros we're going to have. Okay? So we're going to turn over on the back side. I'm so glad that you think so. And we're going to decide on the back how many x-intercepts it has. If I can see the x-intercepts, those are real roots. If I can't see them, if they have 0 x-intercepts, what would we know about their solutions? Are they real? They're not real numbers. They're imaginary. They're imaginary. So if that parabola is hovering over the x-axis, we would have imaginary roots. Okay, so let's look at the backhand side. Let's look at the roots. Or, I'm sorry, not the roots, the graph. Let me pause this. We're going to look at the graphs on the back.